Hello, Chem students. Today we are discussing scientific notation. So, what is scientific notation anyway? Scientific notation is used to represent numbers that are very large or very small. It looks like this on paper. It always has a times 10 to the some exponent. A number times 10 to some exponent. So there are some rules to go from decimal number to scientific notation, which you're going to want to do. You're going to move the decimal point to the left or to the right so that only one non-zero digit remains to the left of the decimal point. So you will have some number to the left of the decimal point, just one number. The exponent is the number of places that you moved the decimal point. If you moved the decimal point to the left, the exponent will be positive. If you moved it to the right, the exponent is negative. Let's go through some examples here. We are going to convert these numbers into scientific notation because it's a large number. If you notice here, we only have 3 significant digits. So in our answer, or in our scientific notation, we will only have 3 significant digits. Now, our decimal point is right here. We don't see it, but it really is here. And we are going to move it to where there is only one number to the left of it. So here's 1, 2, 3, 4, 5, 6, 7. And if I move it right here, there will only be one number to the left of the decimal point. So it is going to be 7.51 times 10, and it's how many spaces I moved. And I moved it 7 places. And since I moved it 7 to the left, my number, my exponent, will be positive. Another way to look at it is this is a very big number. So this number needs to be positive and not negative. Now let's go to our next example. Our significant digits here, we have 1, 2, 3, 4. I'm going to move my decimal point over to where there's only one to the left of it. So there's 1, 2, 3, 4, 5. There's only one number, non-zero number, to the left of the decimal point. So our number will be 3.549 times 10. Now the exponent is the number of spaces that I moved, and I moved it 1, 2, 3, 4, 5 places, so it'll be a 5, but I moved it to the right, which means it will be a negative number. All right. Another clue here is if this is a very small number, then this has to be a negative number. Now lastly, we cannot forget this negative sign in the front. All right, now I would like for you to convert these two numbers to scientific notation and then come back and check your answer. So pause the video, please. Here are your answers. Check them to be sure they're correct. If it's a big number, the exponent will be positive. If it's a very, very small number, the exponent will be negative. Now we're going to convert from scientific notation to decimal point because you'll want to do that too. The first thing you're going to do is move the decimal point to the right if the exponent is positive. So you're adding zeros if you need to. Move the decimal to the left if the exponent is negative. You will add zeros if you need to. All right, our exponent here is positive, which means this is really a very big number. So we are going to move it to the right, 3 places. So I'm going to rewrite it over here, 1, 1. Now I'm going to move it to the right 3 places. 1, 2, 3. Here's our new decimal place, and I need to add zeros where I have empty spots. So our new number is 1,100. Now I'm not going to add my decimal point here. Okay, we know it's there, but I'm not going to add it because that will make these numbers significant, these zeros significant, and we do not want to do that. All right, next example. Down here, 1.12 times 10 to the minus 3. This is a negative 3, which means this is really a very small number, and I need to move it to the left, the decimal point to the left, to make this number smaller 3 places. So I'm going to rewrite it out here, 1.12, and I'm going to move it to the left 3 places. 1, 2, 3. Here's my new decimal, and I need to fill in my empty spaces with zeros. Okay? I always prefer to put a 0 in front of my decimal place. So I'm going to do that. 0.00112. So 1.12 times 10 to the minus third as a decimal looks like 0.00112. Now I would like for you to pause the video and try these two on your own and then come back and check your answers. All right, check your answers. Now we're going to go over correcting scientific notation. First step is you move the decimal so that only one non-zero digit remains to the left of the decimal. You increase the exponent if you move the decimal to the left, and you decrease the exponent if you move the decimal to the right. Sorry, this should say right. An example would be if you have 12.5 times 10 to the 5th. You need to correct this because remember you should only have one decimal place to the left, or one number to the left of the decimal. So we need to move this decimal one place over, so it would be 1.25. I moved it to the left, so I need to increase my exponent.